Myself, I am Dr. K. Prasad, Institute of Aeronautical Engineering, Associate Professor of Physics. Today, we are going to discuss on problems on crystal structures. First problem on crystal structure, calculate the number of atoms per unit cell. Means they are asking for to calculate the number of atoms per unit cell of a metal with lattice parameters they are given is 2.9 angstrom and given molecular weight is 55.85 kg per meter cube and density they are given is 7870 kg per meter cube and Avogadro number is 6.023 into 10 to the power of 23 kg per meter cube. So here we need to solve the number of atoms per unit cell. What is the formula? We are having given lattice parameters means ABC are the lattice constants and alpha, beta, gamma are the interfacial angle. These all are called as a lattice parameters. So within that A is equal to B is equal to C and alpha, beta, gamma is equal to 90, then A is equal to 2.9 angstrom. A is equal to 2.9 angstrom. 1 angstrom is equal to 10 to the power of minus 10 meters. So next one, what they are given, molecular weight M they are given. So that one molecular weight M is equal to 55.85 kg per meter cube. And next one, density is 7870 kg per meter cube. And Avogadro number capital N A is 6.023 into 10 to the power of 26 kilo per mole. So what they are asking to calculate number of atoms. Then what is the formula? Rho is equal to N into rho is equal to N into M by Na into volume. Volume is AQ. So this is the formula. So here what they are asking to calculate means N is equal to rho into Na into AQ denominator. What is the value? M is the molecular weight. So within this formula, just we need to substitute N is equal to rho into Na into AQ by M. Just we are substituting the values. We already mentioned the values. So after substituting, what is the value we are getting? Nearly 2.06 value we are getting. 2.06 we are getting the value. So here 2.06 that is approximately equal to 2. So these related to the body centered cubic structure. The number of atoms are body centered cubic number of atoms is 2. So we got 2 is the value for number of atoms per unit cell of a metal. N is equal to 2. Next problem. What is the second problem they are asking? Chromium has body-centered cubic structure. Body-centered cubic structure. How many number of atoms? Means N is equal to 2. Next, atomic radius. R is equal to 0.1249 nanometers. Calculate the free volume per unit cell. So free volume per unit cell they are asking. Means what it means? Body centered cubic structure, atomic packing fraction, how much? 68%. Free volume, how much? 0.32. 0.68 minus 1 minus 0.68 is equal to total volume of the. So just we are calculating atomic radius R is equal to 1.249. Then free volume of the unit cell we need to calculate. So this free volume unit cell is nothing but total volume for body centered cubic structure. How much it is occupied? Body centered cubic structure is having the atomic packing fraction value is atomic packing fraction value of body centered cubic structure is 0.68. Then how much is the leftover volume? Free volume is equal to 1 minus atomic packing fraction of body centered cubic structure. So atomic packing fraction for body centered cubic structure how much? Point atomic packing fraction for body centered cubic is 1 minus 0.68. So nothing but we are getting for 0.32 percentage is the free volume of the unit cell. Means this value how we will use means just see in the slide. So free volume per unit cell of the body centered cubic is 0.32 percentage, and what is the atomic radius? R is equal to 0.1249. So we need to calculate first A value means lattice constant. So then what is the relation between atomic radius and lattice constant for body centered cubic structure? R is equal to root 3 by 4 root 3 by 4 A. So just we are making for already it is given the what is the value atomic radius R is equal to 0.1249. So we need to calculate for A is equal to 4 R by root 3. So what is the lattice constant value? 4 into 0.1249 divided by root 3. So that value we are substituting, then we are getting the resultant value is 2.884 into 10 to the power of minus 10 meter is the value for lattice constant. So this lattice constant value we are going to substitute in the free volume per unit cell of the body centered cubic structure. So therefore free volume per unit cell for body centered cubic structure is 0.32 into A cube. A is the lattice constant for body centered cubic is 2.884 into 10 to the power of minus 10 meters we got just now. So that value we are substituting here. Then resultant value we are getting is 7.676 into 10 to the power of minus 10 nanometers. That is the value for free volume of per unit cell. Next problem. Copper has face-centered cubic structure means copper have a face-centered cubic structure means face-centered cubic structure. How many number of atoms? Means that is 4 number of atoms. Atomic radius they are given. So atomic radius R is equal to A by 2 root 2. R is equal to root 2 by 4A. That is the atomic radius to lattice constant relation. So atomic radius how much value they are given? 1.278 angstrom. What they are asking? Calculate the density of copper crystal. So they are asking for what? Which parameter they are asking? Density. Density is equal to how much? Then what is the Another value they are given atomic weight, means that is nothing but molecular weight they are given is 63.5, and Avogadro number we already knows. So here atomic radius to lattice constant, what is the relation we need to know for face centered cubic structure. So here given values are atomic radius R is equal to 1.278 angstrom. Then they are given for molecular weight is 63.5, and face centered cubic relation is R is equal to A by 2 root 2. Then we are getting A is equal to lattice constant 2 root 2 into R. What is the radius value? R is equal to 1.278 angstrom. So 2 root 2 into 1.278 angstrom, that is nothing but we are getting 3.64614 angstrom. What is the value of Avogadro number? 6.023 into 10 to the power of 26 kilo per mole. So we are substituting the density formula rho is equal to N into M by Na into A cube. So that formula just we are substituting. Then we are getting, we already knows for face centered cubic structure, what is the N value? N is equal to 4. N is equal to 4 means what it represents. N is equal to 4 is the number of atoms per unit cell in a face centered cubic structure is 4, means we are getting values 8 into 1 by 8, 8 corners, 1 by 8 contribute for each corner atom, 6 face atom, and half of the corner atoms, that is nothing but 3 plus 1 is equal to 4 number of atoms per face centered cubic structure. Just we are substituting N is equal to 4, then molecular weight 63.5, then Avogadro number we know 6.023 into 10 to the power of 26 into lattice constant. What is the value we got? 3.614 into 10 to the power of minus 10 meters. Angstroms we are representing in meters. So 10 to the power of minus 10 meters. So here we got a resultant value is 8.92 into 10 to the power of 3 kg per meter cube. Next we are going to the next problem. Fourth one is show that in a simple cubic lattice, the separation between successive lattice planes 100, 110 and 111 planes are in the ratio 1 is to 0.71 is to 0.58. So, what they are, we know for the separation between the successive lattice planes, interplanar spacing distance between, what is the formula we know? D is equal to A. D is the interplanar spacing. A is the lattice constant. HKL are the Miller indices planes. So that formula is D is equal to A by square root of H square plus K square plus L square. Means show that in simple cubic lattice, the separation between successive lattice planes 100, 110, 111 are in the ratio 1 is to 0.71 is to 0.58. We need to show. So we know the interplanar spacing with lattice constant formula is D is equal to A by square root of H square plus K square plus L square. So what are the planes they are given? 100, 110, 111 planes. What we need to show? That are in the ratio this one. So we need to substitute the values of HKL values in where? We need to substitute in the interplanar spacing formula. So D is equal to A by square root of, here which plane we are taking? 100 plane. So 1 square plus 0 plus 0. Then we are getting A. Likewise, 110 plane we are getting for A by root 2. Likewise, D triple 1 plane, what we are getting? A by 1 square plus square root of 1 square plus 1 square plus 1 square is equal to A by root 3. Then that particular ratio 1 is to 1 by root 2 is to 1 by root 3 is respectively 1 is to 0.71 is to 0.577 values we are getting. So it is proved from this interplanar spacing formula. We are proved that 100 plane, 110, triple one planes are in the ratio in the order of 1 is to 0.71 is to 0.58. Next problem. Find the Miller indices of a set of parallel planes which makes intercepts in the ratio 3a is to 4b on the x and y axis and parallel to z axis. ABC are the primitive vectors or translational vectors of the lattice. Then what is the values they are given? Here, intercept 3a, 4b. If a plane is parallel to axis, then the corresponding intercept is infinity. So, means C plane is nothing but it is infinity. So, we can take as PQR, we are giving the representation PA, QB and RC. So, here what we got 3A, 4B and ZC. ZC is RC. RC is equal to nothing but here infinity. So that infinity value we are taking. So this expression how we can write PQR reciprocal. Next step is first step is HKL is equal to 1 by P, 1 by Q, 1 by R. 1 by R. It is 1 by R. 1 by R is equal to 4 is to 3 is to 0. Just it is a reciprocal and we are taking for LCM. That resultant value we are getting for 430. Means how we are getting 1 by P. 1 by P is equal to 1 by 3. Then 1 by Q is nothing but 1 by 4 is to 1 by infinity is nothing but 0. So 1 by 3, 1 by 4 is to 1 by infinity. 1 by infinity is nothing but this value is 0. Here LCM, what are the value? 3 4 ja 12. 12 divided by 3. 12 divided by 4. Then what is the value? 4 3 ja 3 4 ja. So we are getting for 4 is to 3 is to 0. So we got the Miller indices values are 430. Next problem. In a triclinic crystal, a lattice plane makes intercepts of length A, 2B and minus 3C by 2. Find the Miller indices of the plane. What they are asking to calculate Miller indices of the plane. What are the intercepts they are given? PA, QB, RC is equal to A is to 2B is to minus 3C by 2. So, given is intercepts are A, 2B and minus 3C by 2. Miller indices how we need to write? So, here 1, 2 minus 3 by 2 because A, B, B, C, C are get cancelled. We are taking for PQR. So, this reciprocal means 1 by P, 1 by Q, 1 by R. So, what is the LCM we got? So, the resultant values we are getting is 6, 3 and 4 is the HKL Miller indices value is the resultant one. Finally, we got minus 4 we can represent in Miller indices form is bar. We cannot represent minus. Minus we are representing in Miller indices form is bar. Next problem. Determine the spacing between 100 planes, 110 planes and 111 planes in a sodium chloride crystal having the lattice constant. What they are giving? They are asking for to calculate the interplanar spacing of 100, 110 and 111 planes in a sodium chloride crystal having the lattice constant. Means earlier we just calculated the interplanar spacing formula is d is equal to a by square root of h square plus k square plus l square. So corresponding planes we are taking means we are able to get a by root 2, a by root 3. But here they are given for lattice constant value also. So that is a is equal to 5.64 angstrom. Just we are having the formula is d is equal to a by square root of h square plus k square plus l square. Corresponding plane for D100 plane, A is equal to 5.64, square root of 1 square is nothing but we are getting same value, and a D110 plane case D110 5.64 square root of 1 square plus 1 square nothing but root 2. Root 2 is equal to 1.414, 5.64 numerator getting cancelled, we are getting the resultant value 3.988. D111 plane is nothing but lattice constant is 5.64. We are substituted and 111 planes means root 3. Root 3 into numerator is 5.64 divided by root 3 is nothing but we are getting 3.256 angstrom. Next problem. The distance between 110 plane in body centered cubic is 0.203 nanometer. So calculate the size of the unit cell of the radius of atom. So what they are given? Given are Miller indices plane, that is 110 plane, and interplanar spacing they are giving. Distance between means interplanar spacing. D is equal to how much they are given? Distance is 0.203 nanometer. What they are asking to calculate the size of the unit cell of radius atom. So we know the values. D is equal to a by square root of h square plus k square plus l square. So what are the HKL planes? That is 110. So just we are substituted, and what is the distance they are given? A, D. So we need to calculate the lattice constant first. A is equal to D square root of h square plus k square plus l square is nothing but D is equal to 0.203 into 10 to the power of minus 10 meters square into square root of 2. Nothing but 1 square plus 1 square plus 0 square is nothing but root 2. And we are getting the value is 0.203 into root 2 is nothing but A is equal to 0.287 nanometers. What they are asking? Calculate the size of the unit cell. That size of the unit cell for which value? Body centered cubic structure. So what is the radius formula? R is equal to root 3 by 4a. So we know the value of lattice constant a. Root 3 into 0.287 by 4 is nothing but we are getting the 0.1242 nanometers. Then size of the unit cell is nothing but volume of the unit cell. Volume of the unit cell is formula is for face centered cubic or body centered or simple cubic structure is always volume is A cube. So A cube is equal to A is the how much is the value? A is equal to 0.287 nanometers. That one we are squaring in 3 times. Then we are getting the value is 23.63 into 10 to the power of minus 30 meter cube. That is the size of the unit cell of the body centered cubic structure. Now, ninth problem, A copper has a face-centered cubic structure with atomic radius 0.1278 nanometers. Then what they are asking, atomic radius R they are given. They are asking to calculate the interplanar spacing for 111 plane and 321 plane. So what is the atomic radius? R is equal to 0.1278. Then what they are asking for, interplanar spacing of 111 plane and 321 plane. What they are asking, which structure they are asking, face-centered cubic structure. Face-centered cubic structure, what is the atomic radius? R is equal to A by 2 root 2. What they are asking to calculate interplanar spacing. So A is equal to, how we can write the relation they are given for radius. So lattice constant we can find out. So A is equal to 2 root 2 into R. R is the value 0.1278. So we are getting for 2 root 2 into 0.1278 nanometers is nothing but 0.361 into 10 to the power of minus 9 meters. So we are getting the resultant in terms of angstrom is 3.61 angstrom. Then we need to calculate the interplanar spacing of 111 and 321 plane. What we know, interplanar spacing, A lattice constant we got from the formula, that is 3.61 angstrom. So we can substitute for 111 plane 3.61 divided by square root of 1 square plus 1 square plus 1 square. That is nothing but 0.2086 nanometers. Likewise, we need to take for 3.61 angstrom divided by square root of 3 square plus 2 square plus 1 square. Then we are getting 0.0965 nanometers. That is the separation between the planes values we got from this problem. Now, next we are having potassium chloride in a face-centered, means it is a face-centered cubic structure. They are giving the density, that is 1980 kg per meter cube, molecular weight is 74.6, and we know the Avogadro number 6.023 into 10 to the power of 26 kilo per mole. And what they are asking to calculate the distance from one atom to the next atom on the same kind, and also they are asking to calculate the distance between adjacent atoms. So what is the data they are given? Density is equal to rho is equal to 1980 kg per meter cube, and they are given molecular weight is 74.6. They are and Avogadro number is 6.023 into 10 to the power of 26 kilo per mole. They are asking to calculate, and number of atoms for face-centered cubic structure is 4. Now we need to calculate the lattice constant. A is equal to n into m by rho into Na whole power of 1 by 3. So we know face-centered cubic structure is having the number of atoms is 4, n is equal to 4, molecular weight they are given is 74.6 divided by density is 1980, then Avogadro number is 6.023 into 10 to the power of 26, that is equal to 6.3 angstrom we got. So here what they are asking, distance between the atoms of same kind. So in potassium chloride, that is equal to 6.3 angstrom. The distance between the adjacent atoms, that is having the formula is R is equal to A by 2, nothing but. So A by 2 means half of the value of adjacent atoms. Means same kind means 6.3, different kinds means divided by 2 means half of the value. So that is 3.15 angstrom. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.